I'm Paul with the Shed Lab in MIT's EHS department, and we are going to walk through using Ultimaker Cura, a slicer software for 3D printers. Let's jump into it. All right. Share my screen. This is I believe it's an open source software, but it's a free download. And share my screen. And you can get to it just by Googling Ultimaker Cura. It will take you to the download page. You can download it. When you initially download it, there are a couple presets that may be different from what I'm using, and I'll do my best to show how you'll change those for the printers in the Shed Lab. However, that is me working from memory. So, yeah. I'm going to open up Ultimaker Cura. So what this software does is it takes a CAD file for your part, a CAD file in the format .stl, which may stand for stereolithography, which is a name for one kind of 3D printing process. Either way, here we are. We are using Ultimaker S5s in the lab. So in the top left, there's a pull down where you can add or manage printers. I have the Ultimaker S5 and the Prusa i3 on there. The Prusa printers have their own slicer, which also can make files for the Ultimaker. Some people have strong feelings about which slicer to use. I am not one of them. We'll pick the Ultimaker S5. Across this ribbon is where you set your different print parameters. So the Ultimaker S5 has two extruders. I have them both set to extrude PLA with a AA 0.4 millimeter print core. This is how the printers are normally set up. When they show up, often extruder 2 is set up with a support material, which is PVA, and that is a water-soluble support. If you use PVA, you need to change the print core to a BB 0.4, and you'll need to do that on the printer. There's a walkthrough for how to do that on the printer, and it is beyond the scope of this walkthrough. I'm going to pick generic PLA. I'm going to keep these changes, and I'm going to switch this back to AA 0.4. I'll keep the changes because we're running two different colors of PLA. Great. In the top right pull down is where you set your print settings. The most useful of these is the printing profile. What this does is it sets the thickness of your layer height. So the slicer, what it does is it takes your part in a 3D model and separates it into layers and then creates a 2D path on each layer. We're going to talk about that in a minute. And stacks those layers on top of each other and exports a text file that the printer reads. You can choose how high those layers are. If you want super fine detail and you don't want to see the layers, you can choose thinner layers. I tend to not care about seeing the layers. I know that it's a 3D print, and I want just a thing with a geometry. So I usually choose extra fast. You may want to use a different one depending on what you're printing. If you're printing like little figurines, you probably want a small layer height. I typically am not. Great. And then there within these, for each extruder, there are all kinds of settings you can change. Generally, you don't need to. There are things that are worth talking about. The walls and the wall thickness and the wall line count. It's very common that users attempt to modulate the mechanical strength of their parts by changing the infill You'll see when we do the preview of the prints are mostly hollow, and there's an infill that allows you to print on top of it, but it's like a honeycomb or a grid, or triangles in this case. The infill does not need to be very large, and you can typically increase the mechanical strength of your part by changing the wall thickness where the principal major stresses tend to be. Anyway, right. The material, you can change the printing temperature and the speed and the travel and cooling. You generally want to enable support. You can change the build plate adhesion. The default is brim. I find that it works fine, and I haven't felt the need to change it. Cool. So there it is. Extra fast 0.3. You need to load an STL file. So you can get these from your favorite website that lists STLs. Thingiverse is one, GrabCAD is another. Googling name of the thing you want, STL, is another common solution. They're usually just crowdsourced submitted, so the quality varies wildly. They may also be optimized for someone else's printer. They almost certainly are. Okay, anyway, I need to open a file. I'll click the folder button, and it's going to take me to this defaults to my downloads, which is fine. Oh, here we go. This is a good example. So I've opened this thing, I'm calling it the cable cradle, and it opens in, it may be like this. It depends on how you defined it in your CAD. You can move it around, but it's highlighted with these arrow keys. As you move it around, you want to position it on the bed of the printer. This drop-down model checkbox will set it on the print bed. You want it to set on the print bed. Normally, there are strategies where you print support underneath the whole part, but they're relatively rare. Cool. So I have this part. I always forget how, there we go. And if you look underneath it, I'm changing the camera angle with a right mouse key hold and then mouse move. You can see there are these areas highlighted in red, and those are unsupported overhangs. So the way that it works, we're just going to slice this. So you hit slice and it generates the code. And then I can preview it. And this will show the different layers. So there are progress bars that will take you through the different layers. So this shows you what the printer stacks up. It's coming around, it's making this light blue support, and the yellow is the model material. And then you can scroll through the layers. You can see that there's, I'm panning with holding the mouse wheel and moving the mouse. You can see there are triangle infills and a wall. And then the blue is a support. And that's just an infill that will tear away because there are no walls around it. Yeah, so this takes you through the whole thing. I'm making a lot of support to support this great big overhang. It looks like that. This does allow a couple things. The support is on an area that I'm not particularly worried about cosmetically. This is made for cable management, and it grabs a bunch of cables in here. So I don't really care if the surface here is ugly. I could orient it another way. So you may want to change the orientation of your parts to minimize support or shorten the print time. The print time is mostly dependent on the number of layers. So I could go back to slice, which is prepare. And I can move this model. So you can move it. You can scale it if you wanted it to be a different size. It's really common to scale these from inches to millimeters because you defined your model in one set of units and you'd like it to be in another. You can rotate it using rotate all the time. There's a free rotate where you can use these arrows. And it crashed. Whoopsie. Let's open that back up. It's a little bit rare, but if it happens, it's just not that big a deal. Right. I have my part. I can rotate it. You can rotate it with these arrows. You can also lay flat. I found it to be not super reliable. You can just hit Control Z and select the face to align to the build plate. Is actually quite reliable. You click it, then you click on the. And now that I've said it's quite reliable, it's not going to work for me. Usually I have really good luck with this one. There we go. I'll pick drop down model. And you can also choose edit, arrange all models, and it will place them on the build plate. If I do this way, there will be support in the holes, and I think there's pretty minimal support on the rest of this. Let's slice it and see what happens. So this is a 12.5-hour job. I can preview it. You'll see there's support underneath all of these fillets and support underneath this hook. If I rotate it this way, arrange them, slice it. I'm using support under here, but I've changed this print job time from, oh wow, it's much longer. I expected it to be shorter because the part was taller, but this is now a 16-hour, 30-minute job instead of a 13-hour job. So you could save some time if you did it the other way. Because they're both pretty long and it's going to be overnight either way, I would probably do it this way, and the support will be easier to remove, and I won't have to remove it from the holes, which is annoying because I want the holes to be in my part. I don't like to pry away the support with the needle nose pliers. There you go. So now you have your part. You're ready to do some printing. You need to find a flash drive. There we go. There are flash drives in the printers in the lab. I would advise you to take your laptop into the lab, take that flash drive, put it in your computer, save it to the flash drive, take it out, and run it in the printer. But it's up to you. And save it to the removable drive. So once it's detected there's a flash drive, the removable drive in your computer, you can hit save to removable drive. You can change the name if you want, which is here. Well, I can change this to, it's Friday morning today. Or I often like to date these, 230630. There you go. You save it to the removable drive, and then you take that and put it in the printer, and it'll walk you through it. That's it for this demo. Happy printing.